Let's face it, the green energy race is already on. More and more countries are determined to achieve energy independence and to safeguard our natural environment. Pursuing a green energy future can also help create new economic opportunities, new jobs, new industries, new technological innovations. But the big question is, what can countries do to win the green energy race? We believe our political leaders need to create the policy and financial frameworks so that industry can deliver the results. And here to your right, we offer you a series of videos to help you explore these issues much further. And though most races have only one winner, the great thing about the green energy race is this: there can actually be many winners. Let's face it, the green energy race is already on. I think we all know that our planet does not enjoy endless supplies of oil, gas, fresh water, or even clean air, if we are not careful. And for the sake of current and future generations, we have to make the transition to a green energy future as fast as possible. More and more countries are determined to achieve energy independence and to safeguard our natural environment. Pursuing a green energy future can also help create new economic opportunities, new jobs, new industries, new technological innovations. And yes, we believe that wind plays a key role in the green energy race. Wind is cost competitive, is independent of foreign control, predictable in terms of price, fast to install, and above all, it's clean. But the big question is, what can countries do to win the green energy race? We believe our political leaders need to create the policy and financial frameworks so that industry can deliver the results. There are some key elements that policymakers should consider, such as focusing on the cost of energy, providing transparent, long-term and certain public policies, integrating renewable energy into electricity systems, addressing public acceptance issues, and exploiting offshore wind resources. And here to your right, we offer you a series of videos to help you explore these issues much further. And though most races have only one winner, the great thing about the green energy race is this: there can actually be many winners. Thank you very much for your attention.
After decades with volatile fossil fuel prices, and with the increasing economic effects of global warming, the big question is, how do we invest our money to get the most out of our resources today, tomorrow, and in the future?
We need to ask ourselves, do we know the price of oil in the future? And what about the price of carbon, of gas, and what about the cost on the environment? The answer to all these questions is the same. We simply don't know. What we do know is that wind energy has a stable and predictable cost model. There are no fuel costs, no carbon costs, and there are virtually no environmental costs. So all in all, wind energy is a safe bet for our energy future. We need to focus on the cost of energy because energy consumes resources. It consumes cash, it consumes construction materials, it consumes resources that could be used in a different way, just like allocating resources in a household budget. So we need to focus on the cost of energy so that we make sure that we get the most energy out of our money. It's necessary to involve governments in energy in general because energy is a long-term consideration. It isn't just, business and industry that need energy. Society as a whole, consumers need energy. And energy investments, they're long-term investments. They're 20, they're 50, they're 60 years. So you need governments to provide a stable basis upon which you can make those investments. Everybody needs energy. Businesses, industry, consumers need energy. And energy matters for the competitiveness of local business. It matters for jobs. It matters for economic growth as a whole. So you need to focus on the cost of energy. Before we're able to compare energy sources and decide which one is most cost-effective, we need to define cost of energy. And the cost of energy is the cost of generating 1 kilowatt-hour of electricity, not the cost of building the power plant, but the cost of actually generating the electricity at the power plant.
Before you choose your future energy sources, you have to compare the actual cost of each. But how can we make a better and more fair comparison between very different energy resources?
When a city needs to choose what kind of energy it's going to use, it needs to consider the full cost of the energy sources that it's going to choose. So for example, if we look at the cost of fossil fuels, you have the capex, your initial investment, the cost of building your power plant. And then you have the OPEX, the operating expenditures, which include the cost of buying fuel for your power plant. It includes the cost of carbon and other costs. Besides that, you have the indirect environmental costs of this power plant, for example, water use, and then you have potential social costs with fossil fuels, for example, health costs. At the end of the lifetime of your fossil fuel plant, you also have the decommissioning cost, which is taking apart that power plant. When we talk about wind energy has a comparatively high capital investment, but it has low operating expenses because there is no fuel cost and no carbon cost. Wind energy also has virtually no environmental costs and virtually no social costs. And at the end of the lifetime of your wind power plant, the decommissioning costs are also not very large. And finally, if you want to, for example, compare with nuclear power has also a relatively high capital expenditure, and the operational costs for a nuclear power plant include a fuel cost, and it also includes the insurance cost, which is relatively high for nuclear compared to other power sources. There are potentially very large environmental and social costs, and at the end of the lifetime of that power plant, you also have the decommissioning costs because you need to store your waste for a long period of time after your power plant has stopped working.
Many different factors affect the cost of energy. We can all help reducing it, but how? How can both governments and the industry lower the cost of wind energy today, tomorrow, and in the years to come?
Well, Vestas focuses on lowering the cost of energy through improvements in our technology. Our turbines are made for specific kinds of sites and specific kinds of wind speeds. And by optimizing the turbine to each site where it's going to be installed, we ensure that we get the most power out of every blade and every turbine compared to the megawatts installed. For example, governments have a role to play in that by reducing risk in the political and regulatory framework. Because if you have an uncertain political and regulatory framework, you increase the risk of your investment, and that increases the interest rate that you pay to get funding for your project, which increases the cost of energy. And governments can also institute, for example, support schemes for wind energy, because a support scheme, it makes your income from a project more stable, and that means that it's less risky and it's cheaper to borrow money for your project, and that also reduces the cost of energy.
The demand for energy will only increase from now on. And when the indirect and real cost of energy is not reflected in the prices, the full potential of wind power is easily misunderstood. But how can wind help us ensure a lower cost of energy going forward?
In any investment that we make today, it's a bet on future energy prices. It's a bet on the cost of fuel. It's a bet on the cost of carbon. It's a bet on the future cost of energy. Wind energy is a good investment going forward because it has a stable and predictable cost model, and because we can predict what the price is going to be, and we know that it's a safe investment. It's a safe bet. Since the early 70s, the price of oil has fluctuated dramatically due to increasing demand and often unpredictable and uncontrollable events disrupting supply. Overall, the clear trend for the oil price points only upwards. Meanwhile, the cost of wind energy has fallen steadily and may continue to do so. We keep the cost of energy low in the future by making the right decisions today about what kind of power that we're going to invest in for now and for tomorrow. Well, governments should choose wind energy compared to other energy sources because wind energy is definitely a less risky energy investment compared to fuel-based energy, because we know that wind energy has a stable and predictable cost model embedded. There are no fuel costs, there are no carbon costs, and there are virtually no environmental costs.
If we want a future with sustainable energy, countries need to integrate renewable energy on a larger scale. How can governments create a political framework that drives the development and integration of renewable energy?
We believe that the foundation to any successful renewable energy industry is rooted in public policies. That is why, in order to drive the market for renewable energy, we need to have public policies that are transparent, long-term, and certain. Only then are we able to drive the demand for renewable energy, as well as provide the certainty that drives investments. Transparency means that the public policy is clear, is focused on the inclusiveness of all stakeholders involved in the sector, both when you design the policy but also when you implement it. Setting long-term horizons on your targets, on your support systems, is extremely important for attracting investors. Certainty means giving the investors the security and the clarity to ensure that the public policy is not changed or altered by the policymakers. It takes time to change an energy infrastructure, and there needs to be a certain transparency about having a true price of energy so people can understand why it's there, why it's needed. It needs to have long-term horizon because renewable energy projects run for 20 to 25 years, and it needs to have the security and the certainty that the policies will stay in place over that long-term horizon for investors to really feel that that market is attractive for renewable energy.
If countries want to increase the level of investments in renewable energy, governments can play a vital role. How can governments promote an investment-friendly market?
We believe substantial goals are necessary in order to signal investors that there will be a market for renewable energy. Governments need to provide security of investments by setting ambitious targets. By setting substantial goals, investors know that governments are keen to transform their energy infrastructure to a green energy infrastructure. What is important here is that with the target, you give your investors the certainty that will eventually drive your market. There are some very good examples out there in terms of long-term targets. China is an obvious one. They have 2020 targets to renewable energy. The European Union has just set a 2020 target for renewable energy. All very good examples of target setting.
Investment in renewable energy can be ignited in many different ways. Governments can introduce several financial schemes that can make a world of difference.
We believe supportive financial schemes are needed to create an effective market structure that improves the competitiveness of renewable energy and establishes an attractive investment environment. There are a variety of different supportive schemes that you can choose from. You can choose feed-in tariffs, you can choose quota systems, renewable energy credits, you can choose power purchase agreements. The important thing here is to look at the maturity of your market, the national goals that you have, and then design the right mix for your markets. A feed-in tariff has proved extremely effective to kickstart a renewable energy growth by putting in stable price frameworks for renewable energy investments. Well, this is not about subsidizing per se. This is about building a market energy infrastructure and the frameworks around it. And basically, if you compare it with the subsidies that flow into fossil fuels annually with more than $300 billion globally, the amount of subsidies is trivial compared to fossil fuels.
To develop a renewable energy project, many stakeholders are involved, and there are many processes that developers need to go through. How can government help more projects get off the ground, and in shorter time?
Many bottlenecks in the project development process occur because of inefficient procedures. Governments can improve the speed of development and the rate of investment in renewable energy by improving the planning and approval process. We'll take wind power as a case. One of the clear benefits of wind power is that it's extremely fast to install. From production to development, it is absolutely the fastest energy source and a renewable energy source that you can have. With long lead time on administrative procedures, you risk losing that benefit. Efficient administrative procedures are characterized by short lead times in terms of project development. It's about reducing to a minimum the amount of time needed for project developers to realize their projects, establishing one central authority, combining all the necessary administrative steps into one-stop shop. Well, the benefits are quite clear. If you have long administrative procedures, cost goes up. And this is all about cost of energy. It's all about sending the price signal to the investors.
Energy production has an impact on the environment, some forms more than others. But is this impact included in the price we pay for energy? What should governments do to make the market more transparent?
We believe pollution from fossil fuel emissions is not free. Addressing this fact, whether through emissions threshold, cap and trade systems, or price on carbon, is the first and major step towards allowing for rational decisions to be made on energy. Well, currently, the market does not internalize the external costs associated with energy production, meaning whenever you burn fossil fuels, you have costs associated with health, with environmental issues, pollution, soil degradation, a lot of issues you need to address, and that needs to be factored into the energy price. By internalizing these costs, you ensure that you get rational energy decisions, that you get a truer price of energy. It is important that the price is high enough to change behaviors both from an individual level, but also from an investment level.
The need for energy will keep increasing as new and old economies develop further. At the same time, there's a global demand for a lower carbon footprint. But how can we meet this challenge? And how can we benefit fully from low-carbon energy resources like renewables?
We believe that in tomorrow's electricity systems, renewables should provide base load. Fossil-fired generation should only provide peak load. On any given day, even if there is no wind in the east, it is probably very windy in the west. So we need to improve the integration of renewables into electricity systems, and we need to share the energy across borders. We need to upgrade electricity systems for renewables because in order to decarbonize our electricity systems, we must be able to integrate renewables in a better way than we are today. If we don't get this right, we will not be able to meet our renewable targets and bring down the emissions from our electricity systems.
Today, the demand for electricity is met roughly the same way around the world. But how can we lower the carbon footprint by integrating more renewable energy and still meet the consumer's demand for more and more energy?
Electricity systems of today were built for a very different purpose, with centralized power stations covering the demand in a one-way flow of energy from the power stations to the consumers. The power demand for electricity follows almost the same pattern in every region. It peaks during daytime and then it declines through the evening and nights. Since we cannot store electricity in today's systems, we need to have supply and demand balance at every moment in time. We would typically meet the demand by first adding fossil fuel-fired generation like coal, gas, And then on top we would have solar and wind. In the future electricity system we need to integrate a lot more renewables. And this means that we basically need to turn it upside down so that we place renewables in the bottom, and then the fossil-fired generation is going to be on top, taking the peak loads. That will bring the benefit that we fully exploit the renewable resources available to us. We bring down emissions, and we will also make sure that we lower the total cost of energy to consumers. When it's very windy, we use the strong input from wind to cover the demand. When it's very sunny, we need that to cover the demand. So altogether, this will mean that on most days we can cover the bulk of demand with renewables.
Less than 5% of all electricity is shared across national borders today. Most countries are focused on their national energy supply. So why should governments consider sharing their electricity from renewables with their neighbours?
In order to reduce the cost of energy from renewables, we need to tap into the resources where they are strongest. Mother Nature has distributed our renewable resources unevenly. Imagine that we are looking at, say, 20 countries, and in the north we have strong wind resources and strong hydropower resources. Further south we have countries which have strong solar resources and a lot of biomass. And if we can interconnect these different areas with a system of highways allowing the renewable energy to flow freely within the total area, we will have a very, very strong generation of renewables on a day where we have lots of wind, lots of hydropower, but not so much sun and not so much biomass, or the other way around. We need to cover demand at any point in time, and with such an interconnected system, we have a lot of options to make sure we can do exactly that. The consumer will benefit from this because it is a lot cheaper to produce the renewable energy where the resources are strongest. So in the end, this will bring lower cost of energy to the consumers, lower electricity bills.
To really benefit from the renewable resources, they need to be integrated into electricity systems. And these need to be interconnected across borders. But who should take action to develop these new energy highways?
We need governments to take action on a number of issues. Firstly, we need them to set planning rules so that we get a fixed time frame for planning permissions for infrastructure. Secondly, we need them to set financing options that will allow the infrastructure to actually get built. And this in particular is very important for the cross-border infrastructure, the highways transporting electricity from one country to another, because this is really today the big bottleneck that we are facing in a number of countries. But what governments will get in return is a free and open exchange of electricity across large areas, which will benefit the consumer with lower cost of energy.
Issues like noise and health, visual impact, and wildlife are often debated when discussing wind energy. But what are prejudices and what are facts when discussing the benefits of wind energy?
Vestas welcomes the public debate about wind energy, and we hope to provide factual inputs and balanced perspectives on the different issues. This can help shape the debate in ways that lead to better informed decisions about creating a greener future.
Wind turbines do create sounds when the blades rotate, but how much? And what can be done to limit the sounds people are exposed to?
When local communities want to limit the sounds from wind turbines that residents are exposed to, public authorities have a range of options available. In these cases, Vestas recommends relative noise limits that take into account local background noise levels. This can ensure minimal noise disturbance for wind turbine neighbors while allowing for more wind turbines to be located in relatively noisy areas, such as near industry or roads. These noise limits relative to background noise can also be supplemented with absolute maximum limits in areas of very low background noise, like in the countryside. It's important to acknowledge that the swooshing sound the blades make can bother some people. Most people don't live or work right next to a wind turbine, so the sound is typically measured at the nearest dwelling. In Denmark, the sound limit is 44 decibels outside the nearest dwelling, which would typically be some hundreds of meters away. That's somewhere between the sound your refrigerator makes and a normal conversation. Technology can also make a difference in terms of minimizing the sound from wind turbines. Vestas designs its blades to capture the maximum energy from the wind, while at the same time creating as little noise as possible. That's why one of Vestas' newest turbines, the V112, has 2 different sound modes to accommodate requirements in different circumstances.
Some people are concerned about the potential health effects of low frequency and infrasound from wind turbines. But are there any health risks related to these sounds?
The issue is not whether wind turbines emit low frequency or infrasound. They do. The issue is whether these sound emissions have negative health consequences. And the answer to this question is no, they don't. There are numerous scientifically based, peer-reviewed studies that examine the question of low frequency and infrasound impacts on human health. The science shows that there's no correlation between sound emissions in these ranges and negative health consequences. There is one study that alleges that there's a connection between low frequency and infrasound and human health impacts. That study, however, has been refuted by internationally respected scientists. These experts question the methodology that's used in this so-called study. For example, the statistically insignificant sample size of 10 self-selected families, the absence of a control group, and the fact that this study has never been published in a peer-reviewed journal.
Some people don't like the way wind turbines look in the landscape. A valid question is, how can wind turbines blend better into the local surroundings?
Vestas uses powerful software to show how wind parks will look in the surroundings. This can help position the turbines to minimize their visual impact. In the end, though, we can't escape a simple truth. Beauty is in the eye of the beholder. Some people like the way wind turbines look, others don't. For example, one can position the turbines in an arcing line rather than a grid formation. This was done on a wind park off the coast of Copenhagen very successfully. With regard to aviation lights, for example, one can synchronize the lights so that they don't blink like an amusement park. There are also newer technologies, for example, that use radar that can detect when an aircraft is approaching and then automatically turn on the safety lights. This reduces the time that the lights are actually blinking to only those times when it's really needed. It's natural that people might be more concerned about things they're not familiar with than things they are familiar with. Interestingly, there's a study from Scotland that shows that as people became more familiar with the wind parks, they were less concerned about them than they thought they would be before the parks were actually installed.
Wind turbines placed in natural environments will inevitably have some impact on wildlife, primarily birds and bats. But how significant is this impact, and what can be done to minimize it?
Wind energy and its impact on the environment and wildlife is an issue that Vestas takes very seriously. Our view is that well-planned siting of wind turbines is the key to minimizing the impact on wildlife. Compared to other power generation technologies that require mining, drilling, refining, and transporting of fuel sources, wind energy is a very environmentally friendly power technology. Let's take a look at a Canadian study that shows different causes of bird fatalities. Here it shows very clearly that wind turbines have an exceedingly modest impact in terms of bird fatalities compared to other activities. And now, for example, it's common practice to do environmental impact studies before a wind park is actually built. And these studies will look at things like bird populations in the area, their flight patterns, nesting, and feeding habits. And this is done as a way of learning how the natural environment already exists in the area, and then minimizing the impact that we have when we place the turbines in their environment. There are also issues about wind turbines' impacts on bat populations. We have to acknowledge, however, that we know a lot less about these impacts than we do with regard to birds. We do know that bats tend to fly in low wind periods, and that they're affected more by that fluctuating air pressure around the circulating blades more than direct impacts. But much more research is needed in order to find the best possible mitigation strategies to minimize the impacts that wind turbines have on bat populations.
Offshore wind has unlimited potential. But why even consider to go offshore when it appears to be more challenging and more expensive than just staying onshore?
We believe that offshore wind energy will be the next big thing, simply because offshore wind has massive opportunities and unlimited possibilities in the long run. If you look at the development of onshore wind from its early stages and up until today, we can expect the same from offshore. Tremendous progress has already been made, and as the market matures and grows, we can expect to see the costs of offshore come down. Well, you should consider to go offshore if, for example, you're facing constraints on land which limit your potential to tap into the full extent of onshore wind. And also if you have the appropriate conditions for offshore wind, then obviously it makes sense to consider to go offshore. There's unlimited potential at sea, and it makes sense to utilize this vast potential. You can see I'm standing here onshore, and the wind is barely noticeable. But you can see out at offshore, by the way our wind turbines are running, the winds are much stronger, much steadier offshore. If you do not have the appropriate offshore wind resource available or site conditions for offshore, then it does not make sense to go offshore. The largest potential for offshore wind as we see it is typically in the low depth areas of the North Sea, the Atlantic Ocean, the Baltic Seas. We see huge growth opportunities in these areas for offshore wind. A study was made where it showed around the British Isles, if the UK tapped into 29% of the practical offshore resource available, the UK could become a net exporter of renewable electricity from offshore wind. We've seen from onshore wind first movers like Denmark, Germany and Spain create significant numbers of jobs from being the first mover in the onshore wind market. Now with offshore wind, we're seeing countries want to take on this first mover advantage and create significant jobs. Without offshore wind, for example, here in Europe, it will be very difficult for EU member states to meet their European renewables obligations.
Occasionally, statements pop up stating that offshore wind energy might harm marine life. But is that the truth or just a myth?
Naturally, during the construction and installation phase of offshore wind projects, fish, other marine life will disappear. But evidence has also shown that the fish and marine life actually reappear when the projects have completed, and the foundations act as an artificial reef for marine life.
Another statement that often crops up is that offshore wind energy is too expensive. But is that just a myth, or do the facts and figures tell a different story?
Another debate and another myth out there is the cost of offshore wind. Some maintain it being too expensive. But this debate about the cost of offshore wind is very often very confusing. On the one hand, we have high installation capex costs, much higher than for onshore wind, and this is for good reason. We're much further out at sea, a deep waters, more challenging environment with limited weather windows. But what's key here is offshore we have stronger winds, steadier winds, we can build larger turbines with much larger rotor diameters, where we can capture much more energy production from those turbines. And so it's the cost of energy that's key. That's the only relevant measure for offshore wind. Offshore wind is in its infancy and it's maturing. But as it matures and progresses up the learning curve, we see that gap between on and offshore wind narrow, and we expect to see in the future cost reductions for offshore wind.
Offshore wind has become the next natural step for many countries in renewable energy. But if policymakers want to develop an offshore wind market, where do you start? And how do you get it going?
For a start, you may want to look at doing a spatial planning exercise, mapping out what's actually possible off your coast. As a second natural step, you could look at developing the planning regime, the consenting process, the grid regime. How are we going to build electricity grids offshore to get the power from the projects back to the coast, to the populations? It is key that the governments put in place transparent, long-term and certain stable public policies. That will allow the offshore wind market to prosper. It will allow and help industry reduce costs because the industry will have much more confidence to invest, bring in competition, standardization, optimization as the market matures.
Several governments have already kick-started markets for offshore wind. But can their offshore wind ambitions be realised without government intervention? Or do policymakers need to take action? And what does it take if a country wants to benefit from their full offshore wind potential?
There are many things governments can do to drive offshore wind even further. For example, supporting the industry by investing and upgrading in port infrastructure, which is necessary to get these large offshore projects off the ground. By ensuring the offshore electricity grid is in place to bring the power back from these projects to the coast, by ensuring there's a framework in place where the consenting process is streamlined to ensure we don't have long permitting approval timelines. Governments can also play a role in helping industry to reduce costs, for example, by providing funding support for R&D investments, and that will help us reduce the cost of energy for offshore wind, which is in the interest of society.